All right, so we've looked at short-term changes, which changes to the ecosystem that occur on a timescale from days to months to years. So we've looked at a wide range of changes, and then we focused on Australia's climate drivers and what changes Australia's climate from year to year to year. So these are all considered short-term changes, and now we're going to focus on medium-term changes. So medium-term ecosystem changes or environmental changes occur on a scale of multiple years to hundreds of years. Okay, so they're much longer changes. These changes can take up to a human lifetime or more to occur, and therefore they're difficult for us to understand without using scientific reasoning. So we need to have complex data, we need to have good systems in place to actually measure these changes. Otherwise, we can't just observe them in our day-to-day lives like we can the other changes. We know if it's dry or if it's wet from one year to the next, but we find it more difficult to understand if changes are occurring on a bigger time scale unless we record very specific information. And that's, I guess, a reason why with the current changing to our climates, that some people are finding it hard to believe this is occurring because humans just aren't switched on to think about these long-term changes. It's not something that we naturally consider because it doesn't really affect our day-to-day lives. So because of this, we run into changes when considering some longer-term impacts or longer-term changes to the environment. So we'll come across some of those in a moment. So this session, we're going to briefly look at 4 of these medium-term changes. And if any of these are really interesting, you can go and look at them some more. You can do further study on them. But then we're going to then focus on ecological succession as our main focus for medium-term changes. So we're going to look at solar cycles, glacial melting, land use changes, and desertification today, and then ecological succession next week as a focus. All right, so the first one we're going to look at is solar cycles. Okay, so solar, we're thinking of sun. Cycles, we're looking at, I guess, the cycle that our sun goes in. So let's have a talk about that. So around every 11 years, the sun cycles through periods of lots of activity, which we call a solar maximum, and periods of low activity or a solar minimum. And you can see that on the graph below, that around about every 10 or so years, 11 years, we go from a maximum to a minimum back to a maximum, or from a minimum to a maximum back to a minimum. And the solar maximum and solar minimum is related to the activity on the surface of the sun, the solar flares, the storms in the sun, and how much energy is released from the sun. So we see the activity on the sun's surface as sunspots. So these sunspots and flares are a sign of a change in the sun's magnetic field, and sunspots are regions of intense magnetic field which are cooler than the surrounding surface and look darker. And because of these sunspots, there are, I guess, dramatic effects in the radiation that's released from the sun. So flares are caused by the magnetic field rising out of the sun's surface, and they're made of plasma. So when, I guess, some of the sun explodes out of the actual sun, that changes the way that the balance of the sun's magnetic field, and it can flip around. And that's what we see these sunspots are, these flares. Okay. Changes in the sun's output between maximum and minimums are only small, so less than 1% difference between the two. However, that does have an effect. So they don't relate to global warming, but they do influence water and air circulation and can influence cloud cover. So they do influence the atmosphere quite a bit. There are changes in the UV portion of solar spectrum, and that's significant between maximums and minimums. And this influences the chemistry of the stratosphere. So we know that UV light, I guess, gets absorbed into the stratosphere, making it warmer. And if there's more or less of this, then it can change the chemistry of this stratosphere. Solar flares can cause geomagnetic storms, and this affects communication, satellites, power grids, and radio transmissions. So it can have some pretty bad impact for humans, and for parts of our society that we rely on. Cool. Another cycle that occurs over many years to hundreds of years is glacial melting, okay, and glaciers changing. So I'm going to show you some examples of this. Here's an example of this is a photo I took in Patagonia. It's a glacier which is not melting. It's one that's actually one of the only ones that is advancing in the world. And you can see some ice where it had crossed over that channel of water, and then it got broken and worn away by the water, and it will continue to advance once more. Advance over that bit of water, and then it will be broken down again. So that's just the cycle this glacier goes in. But globally, glaciers are melting. And so here's another picture which I also took. And this shows, I guess, a change in a landscape. So this valley here, as you can see, has lots of a very large amount of rubble. The, the rocks are all broken and worn into these big boulders, and the valley is a perfect U shape. Whenever you get a perfect U-shaped valley instead of a V, a U-shaped valley, it is caused from a glacier carving its way through the mountains. And you can see where this glacier once was by the tree line at the bottom. So where those trees are is the extent of where the glacier moved. Since this time, however, the glacier has retreated back up this valley and back up the mountains, and you can see it in the top right corner there. Is now just a small glacier on top of the mountain. So over hundreds of years, these glaciers change, and that triggers landscape changes. And in 100 years' time, this landscape here will probably look remarkably different to the one that is in this photo. And we'll talk about that more when we look at ecological succession. So 10% of the Earth's surface is covered in glacial ice. We looked at that, about the importance of glacial ice, because it's an important source of water for people and ecosystems near them. And the word we give for the solar energy that's reflected from the Earth back into space is called albedo. Okay, so the albedo from glaciers is very high, and dark surfaces have low albedo. So glaciers are very important for reflecting the sun's energy back into the solar system, back into the space and away from our atmosphere. Melting glaciers increase the amount of fresh water mixing with salt water. So in some places around the world, like Antarctica and like in Greenland, where you have large amounts of fresh water being melted and put into the ocean, what occurs is that this cold, fresh water sits on top of this fresh water, sorry, sits on top of the salt water of the ocean, and that changes the ocean currents. And we'll talk more about thermohaline circulation when we talk about long-term changes on this planet. But it changes the circulation of ocean currents, and that can have a huge effect on the Earth's climate. So glacial melting is something which does occur from time to time, and as you can see here, it's occurred in this valley probably over the last few hundred years, maybe even longer. But this valley was once formed from a glacier.